Welcome back to another evening in the planetarium at home with your host, me, Mr. Jason, from your local St. Charles Parish Library Planetarium. Well, normally I've been talking about the stars and all that, but I want to break it up a little bit. I want to talk to you a little bit about, telescopes. Not so much the ins and outs of a telescope, but, how to manage your expectations when first getting a telescope. Often I'm asked about purchasing a new telescope, many times for a young child who's enthusiastic about the night sky. Often we get telescopes that are on the cheaper end and have not so great optics, and that coupled with some grandiose expectations tend to be disappointing for even an adult amateur astronomer starting out, but could also turn off kids who are really curious and enthusiastic and want to see all the wonders that are out there. And there are wonders out there, but they could be let down. While people ask me about buying telescopes, I'm not an expert on telescopes. Often I point people to the local Pontchartrain Astronomy Society. It's our local astronomy society that, it's just filled with amateur astronomers and some professionals that are just love looking up to the sky. They love telescopes and they love sharing their passion. I'm going to put a little bit of information up about the local Pontchartrain Astronomy Society up on our post. But I want to talk today about managing expectations. What are you going to see when you look through a telescope? Often when we think of all these amazing pictures from space, we think of what we see from NASA, from the Hubble Space Telescope, and more. All these amazing, incredibly large telescopes that can gather light and take images of these beautiful nebulae, of our planets, of our solar system, of galaxies far, far away. But we're not going to see that through our small telescopes. So we're going to compare some of the simple objects that you can find and easily find in a small telescope, but we're going to see what they would really look like through that telescope. We're going to start off with, Venus. Venus is big and bright in our western sky as soon as the sun starts to go down. But through a telescope, you're not going to see this. Well, often when we see pictures of Venus, we're seeing actual radar imagery of the surface. When you look through a telescope, though, you're not going to see the surface of Venus because it's shrouded in clouds, really thick clouds. When you look through a telescope, we think we'd see this. And we can see a little bit of clouds here, but that's not what you're going to see through a small telescope. This was taken by the Hubble Space Telescope. Over here, this is more what you're going to see. You can kind of see a gibbous shape to it. Venus does go through phases, so you can see a changing phase to Venus, just like our moon. Right now, we're getting a thinner crescent Venus as it's moving from, being behind the sun from our point of view, around to being in front of the sun, and it's going to be diving down towards the sun as our nights go on, and we'll see more of a crescent shape when we look through a telescope. But this is the gibbous shape. This is what you would see as Venus is rounding around the sun towards us, or moving. Actually, this is rounding around the sun towards us. But we won't see any clouds. You'll see kind of a brightish disk. When we look at planets, we see a disk, more of a circle, but not Venus, and not Mercury either. They both go through phases because they're closer to the sun than us. But what about Mars and the other planets? Well, Mars, we're often looking at this pretty, the red planet. We might see the North Pole, the South Pole. We could see some of the features. Might even see some dust clouds clouding our view. But when we look through a real telescope, through, one of our telescopes, this is what you're going to see. Kind of a little orangish blur. You can maybe see the North Pole, the South Pole. You might see some darker and lighter features. But you really need a larger telescope to start to see Mars and its true red planet grandeur. As far as Jupiter, we are used to seeing all these with the pretty clouds and the great red spot. That's, again, space telescopes, the larger telescopes. And we don't see that. We're going to see more of you might see some stripes, but more importantly, you're going to see the Galilean moons. They're going to look like 4 stars that are lined up in a straight line. Maybe 2 on one side, 2 on the other, maybe 3 on one side, 1 on the other. Or maybe you only see 3. Maybe one's in front of the planet or behind the planet, because these are moons orbiting around Jupiter, the 4 largest moons discovered by Galileo when he first made a telescope and pointed it towards the sky. That's why they're called the Galilean moons. You can see those and you can track them over time. Just go out and look up through your telescope. Jupiter will be rising up in the early morning before the sun rises. You'll be able to spot Jupiter. And of course, Saturn. Saturn's one of the best things to view through a small telescope. But let's not get our expectations too high. We're not going to see this. We're not going to see an image taken like this from the Hubble Space Telescope, or all those pretty images taken by the Cassini spacecraft that's was literally orbiting the planet and sending back pictures. It got an up close view. Our view is going to be a little bit smaller, a little blurrier, but you should still be able to see that ring and the gap between the rings and the disk of the planet. And that's amazing to find and to just see with your own eyes. There are other objects out there we can see. There are clusters and nebulas. One of the more familiar clusters to us, it's the Seven Sisters, the Pleiades. We see pictures like this where we can see some of the bluish nebula, the leftover of the nebula that birthed these stars. This is an open star cluster. But when you look through a telescope, you're not going to see that. That's very faint. You're going to be able to pick it up if you have a really good telescope and a really good set of cameras to take some astrophotography. But when you look through a telescope, you're going to see more like this. You're going to see the bright stars. Maybe a little kind of like a little dipper shape. In fact, lots of people confuse the Pleiades with the Little Dipper, but the Little Dipper isn't a star cluster. It's an asterism and a constellation all rolled up into one. This is not much of a sight, but with a bigger telescope, you can see even more stars in this open star cluster. We can see about 5, 6 with our naked eye. Some people with really good eyes say they can see 7, and it is called the Seven Sisters. But with a pair of binoculars, you can see dozens of stars. With a decent telescope, hundreds, if you want to get out under a nice dark sky. That's the key, being out under a nice dark sky for seeing these star clusters and these nebula. There is one nebula that's pretty bright, and we can spot it even from outside the planetarium we have with our telescope. It's the Orion Nebula. It's setting earlier and earlier now. In fact, it might not be visible in our early evening sky anymore. I'll have to look that up. But the Orion Nebula, we always see these pictures online from NASA of these pretty colors, all the amazing colors. We see stars being born into this region. This is a stellar nursery after all, where new stars are forming and planets forming around them. But when we look through a telescope, we don't see that. We see more like this. It's a little tiny image. You might see some kind of a bluish cloud going on. You'll see some stars in there, which are going to appear brighter. It's going to appear blue because, the blue light is what your eyes can pick up. If you had a camera and took a picture of this image, you might see a little bit more color. Not much, because you need a bigger telescope. But our eyes, we can just barely pick up a little bit of that blue faint nebulosity, a little bit of clouds. And even then, it kind of disappears when you look straight at it. And that's all about how our eyes work. Our cones, where we pick up color, they're centered in our eye. And if you look straight at things, that's where the light's going to hit. But in the low light, we need our rods to function. We need to look at the object, it's called averted gaze. You want to look around the nebula to see it better. It's kind of strange, huh? But you can see some really amazing things under a dark sky, even with a small telescope. Now, one of the easiest things to spot through a telescope, even a small one, even a pair of binoculars, or even just with your eyes, is the moon. And we expect to see through a telescope the moon. It's huge, it's big, it's bright. This is a full moon, which you really don't want to observe the moon when it's full. It kind of just is really bright and washes out everything. You can really see some of the, craters and all that when it's a half moon or a crescent moon. We can see a little bit of the craters around the bottom edge here of our moon, but you'll see more if you're not observing it during a full moon. But this is not what you're going to see through a small telescope at home. You're going to see more of this. You'll be able to spot essentially all of the moon, but it's going to be much smaller. It might be a little hazier. You're going to be able to see the darker areas. You might pick out some of the craters. And well, it's still something really cool to observe. You can look at the different dark areas, those, well, areas we call Maria. Maria just means sea or ocean. In fact, a long time ago, early astronomers, before we had telescopes, we thought that was bodies of water on the moon. And so those dark spots were named after bodies of water, or named as bodies of waters. The Sea of Tranquility, in fact, where the Apollo 11 sat down. But we now know that that's just volcanic rock. Volcanic rock that erupted to the surface and cooled down, forming these darker, flatter areas. This is our moon, and this is our, well, expectations versus reality. And we get asked a lot, why is it that we see all these amazing images from NASA and all that, but we can't see that ourselves? Well, it's a matter of taking pictures. Cameras are much more sensitive to light, but also, you might have heard NASA photoshops all of their images. Well, yes and no. When NASA gets images from its spacecraft, these images are actually black and white. They're taken at a specific, well, wavelength of light, and then they're combined to make them a color image. Here's what I mean. This is our moon image down here, and it was actually made up of 3 different images, each taken at a certain wavelength of light. We can see the light from the Hubble Space Telescope was gathered in the ultraviolet range, and that was used to create this black and white image on the left. Then we have some of this greenish blue light, this teal light, in that one specific wavelength was used to make the image in the middle. And more of a, well, redder and almost to the infrared section, we got our image on the right. And we see the image on the right is a lot brighter because there's a lot more red on Mars, the red planet. So we got a better image. So what they do, they take those individual images, they color them, blue, green, red, trying to match up as best they can to the wavelength of light they're picked up, and then they combine them all to get our color image. And it's pretty close to what we'd see through our telescopes here and what we'd see with our eyes if we were to travel to the red planet. But this is where we're trying to create a visible light image, what we'd see with our eyes, or more of a natural color. But NASA doesn't always want just to see what it would look like with our eyes. Sometimes it's easier to pick apart an object in space if we could look at specific wavelengths of light and then color them to combine them. We can see how these combine. We can tell what kind of gases are there. Are there more gas of oxygen here, more nitrogen, hydrogen here? How's that laid out in the structure? It can tell us about the structure itself, but also what came before the structure, what created the structure. Our next image, well, this is the Crab Nebula. It's really pretty. We see lots of different colors and combinations, but it's actually not what you would see with just your eyes. Because with our eyes, we can't make out this brighter section in the middle. What we see is just kind of these, more of the stronger yellowish filaments that you're seeing, the yellow-green filaments. What you see there, that's more what we'd see with our eyes. And I'm going to show you, we're going to break down this image because this is actually a composite of multiple images taken at different wavelengths. There's red, which was radiolight. This is gas that was heated up by the, more energetic wavelengths of light, the X-rays and the ultraviolet, that was causing these gases to heat up and then give off light their own, but a much cooler light, a lower wavelength, radio waves. And we see here we got a pretty picture here, but it's not the whole picture. This is what it would look like through infrared. We see that this image is not quite as, defined. It's a little blurry, and that has to do with our telescopes. The telescope that took this image didn't have as big an opening, an aperture to gather light. So it couldn't gather as much light, so it couldn't make as sharp an image. The bigger the opening of a telescope, the sharper and more magnification essentially you can get when you look at it, at least for a clear image. Magnification, you can magnify any telescope to any wavelength, to any magnification. It's just, you're going to lose quality and sharpness. Things are going to start to get blurrier. And that's what we have here, where we see our infrared. Our next image, which instead of being colored more of a yellow, it's colored green, and we see it's, well, very crisp, very clean. This is what we'd see in optical light, the part of light that we can see with our eyes, the rainbow of colors. But in this case, it's just colored green. So we can see that this is the structure that we can see with just our eyes. It has its own colors, but in this case, they took in one wavelength and colored it green, so we can overlay it with all these other colors. In fact, even a blue color, which shows ultraviolet light. This is where we start to see a little structure in the middle. This is hotter material. It's giving off a higher energy light. And we start to see kind of this weird structure here in the very center. A little bit of the gas that's actually circling around a neutron star, a pulsar. A neutron star is what's left over from a star that's gone supernova. In fact, the Orion Nebula is a leftover from a supernova that blew up almost 1,000 years ago. When we look at it today, we just see the gas that's been thrown out and expanded over that time. But what doesn't get blown out, the very core of the star that blew up, can be crushed down so much that protons, electrons, neutrons, they all get merged together into a big, thick, well, ball of neutrons. It's incredibly heavy. A tennis ball piece of a neutron star would weigh, well, millions of tons. But we start to see that neutron star in this wavelength because the gas circling around it is super hot. But there's even more. In our last of the five different wavelengths of light, the images, this one, kind of a purplish pink color. This shows us that neutron star. We can actually see jets of material, superheated material, being shot out from in front here and going behind. We see around in a circle the material that's being heated up as it moves around this neutron star. Crazy, huh? And all that combines to make this really pretty image. But it's not what we'd see with our eyes. But it can tell us a lot about our night sky. I'm Jason Talley with the St. Charles Parish Library Planetarium, your planetarium supervisor. And I want to say that we'll see you soon under the dome. Keep helping to flatten that curve. And, well, go out and look up. I'll see you next time.